All right, hi everyone. I'm doing a talk today on event sourcing and CQRS. My name is Quinntyne. I'm an architect and a software engineer. I've been using Angular since 2012. That's kind of my main thing right now. And I've been doing ASP.NET from 2005. So I'm a .NET guy. Oh, and I'm going to be doing a talk today on event sourcing and CQRS. It's just a way of building web applications using this pattern. If you find what I'm saying interesting, pick up this book. This is Domain-Driven Design by Eric Evans. Who's heard of Domain-Driven Design? All right, that's cool. And who's heard of event sourcing? All right, 1, 2, 3, 4. OK, cool. Who's heard of CQRS? Same 4 people. All right, this should be good. If you find this interesting, pick up this book. You won't regret it. So before we get into it, like, what problem does this solve? Like, you want the mic closer? But then I have to. OK, is that good? Better? OK, that's better. All right, so before we get into it, like, what problem does CQRS and event sourcing solve? Like, it's a big name. What problem does it solve? So I'm going to demonstrate one of the problems that it solves through a demo app. All the source code is available on GitHub, and we'll go from there.
Just a quick thing.
Yeah.
For the few people who have no idea what event sourcing is, could you give us a little?
I will, but I recommend this before you dive into something. Understand how is it going to help you? Like, why even do this new pattern, this new technique, right? So what I want to do is just show you an app and show how it solves the problem, and then I'll explain like what it's actually doing, right? Because yeah, I can get into trouble like that. All right. And all this code's available on GitHub, and I'll provide the link after the talk. So this is an app. This is a basic e-commerce app. It's just it's an app that I'll probably be playing with in the future. It's where you can buy services. You can buy training, mentoring, assessment services. It's running locally. So if you log in, the front end's using Angular. The back end's using ASP.NET Core. So you log in, you can buy a service. You see the shopping cart updates one. You want to buy assessments, updates two. You go to the shopping cart, and then you check out. Great. So it's a functional e-commerce app, demo app. But let's say you're running this in production and everything's going great, and like some customer says, hey, 2 days ago, I went to your app and I tried to buy mentoring services and I couldn't buy it. Like, there was just an error. And you say, well, I just ran it, it's working fine. Like, I'm not sure what you're saying. But it's just like, no, 2 days ago, for sure, I went into the app and it didn't work. So what if we can replay the state of the entire system from 2 days ago? What if we can look at the state, the number of users from 2 days ago, the products, all of the content? We can go back 2 days ago and see what the state was. So that's that's one of the things event sourcing does. The event sourcing, you don't store actual models, or you don't have a user table, a product table. You just have a table of events. So one of the things you can do, you can actually go back to the state of 2 days ago. So I'm going to do that now. So inside of my API, this part's not important. I just have a configuration. And X out this file. So I have a configuration here that's just a view at, and I have a date. So this date is from 2 days ago. So I'm going to configure the app to be of the state of 2 days ago. Or I actually think it's yesterday. Sorry. And then I'm going to shut down the app and restart it. All right, looks good. And then we're going to log back in with that user. So I'm going to say, OK, so the guy's name is Eric. He called in and said, I couldn't order the mentoring service. So I said, OK, I'm going to log in with your user. So I say, Eric, OK, so now the state is 2 days ago, and I see that in your shopping cart, you had 2 items, mentoring and assessment. So he said, yeah, like 2 days ago, this is what happened. And I wanted to buy one more mentoring package, but then I got an error. So if I click it, mentoring, there's nothing happening. And if I go F12, there's a bunch of errors. And I say, yeah, like this system is set up as such that you only can buy one mentoring package per session. It's just a fictional error. But the idea is that we rolled back the state of the entire app of 2 days ago to where he saw it, and we fixed his error. So that's one of the benefits. So let's go back to the slides. So basically, event sourcing is an event log of all the events in your application and relying on the event log as a single source of truth. All you do is persist and replay events. You'll get a request from the user, like order product. Your application will change that to an event. Your event will be applied to your models, which will set the state, and then you persist it to the event log. You don't maintain a table like user table, product table, anything like that. So basically, there's only two tables in this entire application. There's one table as a stored event, and basically that's just the event with some metadata, so I know how to rehydrate the app, like the actual .NET type and when it was created on and stuff like that. The other important model is a snapshot. So 3 years from now, when someone makes an order, you can't replay all the events from the last 3 years. So incrementally, you want to snapshot the application state, right? And so you just load the latest application state and then apply maybe the most recent events. This is kind of the events that are in the app. So you have product updated event, role created event, shopping cart item added event, user created event. You have all the events would be specified in these classes. And what's the benefit of this? The main thing is the audit log. If you have anything where you need a full audit log, like such as payroll, anything to do with money is really good. If you're in a highly regulated industry, healthcare, and you need an audit log, this is a perfect thing. Most people don't recommend to do the entire app using CQRS and event sourcing. It's a lot of work. It's a lot to get your mind around. You might want to pick 2 or 3 like critical things where you need to show the exact audit trail of what's happening in your system for whatever regulatory reasons and stuff like that. With this approach, there's no data migrations. You're pushing out a new feature with a whole new module, a whole new set of models and whatever. You don't have to go to the database and migrate and schema updates. Your schema is the same. You have one table, that's your event log table, and then you might have your snapshot table. And it supports cases you haven't thought of yet. You have a transaction and you have a list of all the events that ever happened in your system. You have so much flexibility. If you want to do some crazy report 3 years from now, you'll be able to do that report because you have the raw data available to you. GitHub works like this. Your GitHub repo it's essentially a event source system. Your GitHub repo is the current state of a bunch of transactions, right? Commits, pushes, and stuff like that. Banking, obviously your bank account, your balance is not just some value on a model, right? It's a list of, it's a result of a bunch of transactions, and then you eventually get your balance, right? Netflix has their licensing system. I put a link to the talk after at the end of this slide. Their licensing system is an event source system. It's a system where if you want to download a video on your iPad or whatnot, they use event sourcing. And I'll just quickly touch on CQRS. So CQRS is the idea of separating your queries and your updates and deletes and saves. Why would you do that? If you're doing event sourcing, you have to do CQRS because you query from the state of your system, like the actual application state, and the commands, the updates, you're updating events, you're creating events. So you have to do CQRS. You can separate your query, when you separate your query stack from your command stack, you can scale them independently. So your query stack is going to be really simple. The majority of applications, probably queries, it's going to have caching. It's kind of a separate thing. Your commands, you're going to have validation. You're going to have all this business logic. So if you keep them separate, you can scale them separately, ramp up your querying, as well as use the right technology for the job. So for your query stack, you can just do simple SQL, like SQL queries, get all, get all, get all. For your command stack, might need an ORM, you might need different things, right? So it's kind of, it simplifies development. You scale them separately, yeah. All right, so how do we build this? The main thing is your core model, is your aggregate root, or it's just your base model. And what I want to show is that apply method right in the middle there. And basically, each model in your application knows how to take in an event, apply it to itself so it updates its state, ensure that it's valid, and then raise the event so then it can be later persisted. And this is a lot for a short talk, so all the code's available to, and we're going to have questions after and stuff like that. But that's the root of it. It's really that simple. Your models know how to apply an event to itself, validate state, save the event. Then you have your actual event store that knows how to save the models, and it knows how to provide you a list of aggregates or a list of models on the query side of things. One cool thing to know, if you look in the middle, there's something called a concurrent dictionary. This is for C# though, but basically my app runs the entire application state in memory. That one dictionary, it kind of saves to the database as a background, okay, let's just make sure thing. But really, the entire state's in memory in one dictionary, and that's one of the powerful things you can do with this guy. So this is a user class. And if you look in the middle, you see user created. It can take in a user created event and knows how to update the ID of itself, the salt for the password, the encrypted password. It can take in a user role added event and knows how to update the roles to itself. And there's some minor validation, ensure valid state, where it says, okay, we're valid if the password is populated. Otherwise, we're throwing an exception. And your classes look like this. And it has an add role method that basically, when you want to add a role, it doesn't actually mutate itself. It raises an event. It raises a user role added event that's later played on itself. And it's kind of a lot to grasp, but I just want to get your interest. So yeah, so that's basically it. The repository, Code with QB, is up on GitHub. That's the link to it. Scaling event sourcing for Netflix, that's their talk and how they're using event sourcing on Netflix. And there's a good talk by Martin Fowler on event sourcing, just to explain why you might want to use it, why you don't want to use it. That's it. Yeah.
So, a couple of questions. Question number one, is this paradigm actually available for non-Microsoft environments, or is it?
Yes.
It is?
It's 100% is, and this is just a pattern. I think, I don't know, at Netflix, yeah.
Okay.
It's just a pattern, yeah.
Question number two, so you're saying that this is really storing information in at most two tables, right?
Yeah.
So if you're basically a highly transactional system that stores all these transactions, let's say you have 1,000 transactions
Yeah.
a minute. I mean, would this not be scalable? Like, this is not very scalable, right? Is it?
One thing, what I'm using for .NET is something called a concurrent dictionary. And what you can do with that is you can have multiple threads insert, update, and delete in that dictionary at the same time. So with your particular application, you're right. You have to look at scaling. You have to look at the different limitations of your implementation. This one is for me to understand and learn and kind of explain event sourcing, the event store that I created. You would get something that's open source. There's a lot of open source event stores, and they will let you know about the scaling and stuff like that. You wouldn't write your own. But the models you would write, but not the event store.
Cool. And then one final question.
Yeah.
So this information is obviously stored in hashes or something in databases. It's not like something you can SQL query stuff out of it.
Oh, for sure you can SQL query it. Yeah. So basically, you have to.
Like what the format is.
Yeah.
I
So.
know about it, right?
So let me show you. So this is, I'm not sure, it's kind of, oh, you guys can see it. Okay, hold on. Okay. Slideshow, stop, and slideshow. And now you see code. This is super small. Let's see if I can do something here. No, that doesn't work. Okay, let me just, no, that doesn't work. All right, well, you can basically see the top. You might see tables, or you just see a kind of a folder open. There's only 2 tables. In the application, there's only 2 tables. There's the CodeDB, it just has a snapshot table and a stored event table. Now this application, I'll show you. Yeah, I still have it running, good, okay. So this has, users, login, this has roles, like I'm using my user here. And you can add, there's the list of products. These are just 2 tables, right? So you can handle whatever complexity. You can add a little dashboard onto the dashboard. And all of this is just going back to 2 tables. So there's a lot. You just think of it as like banking, right? Like you have a transaction log. A huge enterprise, it comes down to the ledger. A small business, it comes down to the ledger, right? It scales really well, and you do all the statements from that.
Okay, so you say there's a ledger.
Yeah.
How do you? So I'm assuming there needs to be some sort of global ordering to events, right?
Right.
How do you do that with the concurrent hash map?
Mm-hmm.
Like, how do you ensure sort of absolute ordering of things to recreate the exact same state?
Yeah. So that you would. When you get into concurrency, there's some work you have to do on the request, right? So you have to make sure your request goes in order. So that's something you would have to implement yourself. Like with a database, you can do a lot of role locking and things like that and make sure that that works. You're right. With event sourcing in this system, it's a little more work. But basically what you do is your request, you have to, in your system, you're going to have to write some code to know which request can happen before another request, which request can happen at the same time. But
It sounds very similar to what databases do.
Exactly. Yeah, so that's the thing. You have to re-implement that part. You're right. So as far as concurrency, role locking, making sure the right order of operations is happening.
Try to localize it as much as possible
Yeah.
to the
Yeah.
data set. Okay.
Yeah. You have to write that.
Is there a way to kind of, so this is basically like a log of events.
Yeah.
Right? So if I wanted to drain that into some sort of like distributed store, like is there any sort of, like would you suggest a particular way to kind of cleanly do that? I guess you could use any system, but is there something that's particularly suited to like logs or?
You can, there's different ways. I know there's the Microsoft, there's something called Service Fabric, but there's different of these kind of application management stuff where you can just like when the application shuts down, you can persist the state to somewhere. Okay. You can on your actual application, and depending on what event store you use, you can have an API where you can access all the events.
Okay.
But yeah, so as far as getting access or draining it, you would either use the built-in way when the app shuts down from whatever system you're using. Mine would be Service Fabric. You can push the events to a service bus or some sort of bus, and then something else picks it up and saves it, Kafka, something like that. Yeah, there's various different ways. You have a lot of flexibility.
Okay.
A lot of flexibility. Yeah.
So does this method like sort of let's say you have a database, right?
Yeah.
And you want to like roll back, but you want to look at the state of that database from several days ago.
Yeah.
Like, does your database need to have that ability to go back?
No.
Okay.
Yeah.
So that's awesome. I had a database once where it would run like a massive storage procedure.
Yeah.
And it would, yeah, I know, right? And it would take a long time, but when it was done, there was no way to go back.
Yeah.
Like once it was done, it was done.
Yeah.
It was like a payroll system, anyways, long story short. So you would not need, you could rebuild the state of your database before that transaction occurred.
Right. So basically what that method is doing, it's when I put in that date, it's saying, okay, when we boot up, just take the last snapshot that occurred before this date and just replay all the events that occurred before this date. So really the database doesn't change, but your application knows that date, just replay and build up the state up until that date, and then boom, you have the application in that exact state.
So how long is your boot going to be if it's going to replay that?
snapshots. So it depends how often you do snapshots. So if you do snapshots, like, you know, if your snapshot takes 6 seconds and you do snapshots like every single save, then your initial boot would be 6 seconds. And that's just the initial boot.
Like a petabyte of data, whatever. How would that work? So it has to replay all the events to rebuild to that state, or does it just take a snapshot and rebuild that?
That's your application code. So your application code would say, am I just going to take the latest snapshot, or am I replaying the events on boot up? And remember, boot up is depending on what you use, like various systems.
Let me replay if I need, right?
Yeah.
Let me actually rebuild it like as the events occur.
Yeah.
From the beginning to the snapshot.
Yeah, yeah. But remember, your boot up is like when you push the code to production. That's your boot up. Not customers never. Yeah,
I know
okay.
what you mean. I'm just asking.
Yeah, yeah. So your boot up shouldn't happen too often now.
Okay.